This visual represents our best guess on what is going to happen in the near future with refrigerants in the air conditioning and heat pump sector. Window units, split systems, and VRF systems will gradually shift away from using R410A and toward propane, especially for the smallest charge. A2L refrigerants are expected to be used for higher capacities, but still need some safety endorsement from various standards like AHR15. A2L refrigerants are currently being tested and validated, and results are expected by 2017. For bigger systems such as scroll chillers and rooftop units, a similar transformation to A2L refrigerants like R32 will occur. We will also see HFO blends such as R452B and R454B come into use. The end game also includes some applications using propane, especially in Europe. If we look at the high-capacity area, which includes centrifugal and screw chillers, then we see that the most used refrigerant today is R134A. This refrigerant will also go through a transition to HFOs and blends. Danfoss TurboCore compressor is a good example of this transition, since it uses 1234ZE, which is a very environment-friendly refrigerant. Nothing should hinder this technology from being used at the endgame, and we think HFOs would be a good endgame solution in this area. The refrigeration sector has already used natural refrigerants for many years. If we go back to the Montreal Protocol phase-out of CFCs in the 1990s, we can see that household refrigeration was already using isobutane, an excellent refrigerant for that application and one that will continue to be used. When we look at higher capacity applications, such as vending machines, bottle coolers, self-contained units, and semi-plug-ins for retail, we see that many of these appliances use either propane or CO2. Many of these applications still use refrigerant charges below 150 grams, but that charge size is expected to increase in the future. Commercial refrigeration primarily uses R404A and R134A today. R404A has a high global warming potential, and the emissions from many commercial systems can be reduced considerably by substituting R404A with an alternative. As I mentioned earlier, Europe is facing a dramatic phase-down step in 2018. The majority of this phase-down step will come from refrigeration on the supermarket side as it shifts away from R404A and towards CO2. We will also see a partial transformation to cascade systems where you have a chiller-like solution that uses R134A or R513A combined with CO2, which may be suitable in warmer climates. When it comes to condensing units, we see a changeover to R407A and R407F that has already taken place in many areas. These refrigerants are reducing the GWP impact by about 50%. However, several additional substitutions are emerging. R448A and R449A, which are based on the HFO 1234YF, as well as R452A, which already plays a role. Our portfolio is now qualified for these refrigerants. In the industrial refrigeration sector, ammonia has been a dominant player for many years. The service professionals specialized in ammonia applications are well educated, and ammonia, despite being toxic, is extremely energy efficient and a globally accepted refrigerant for larger applications. Ammonia will remain in use in the short term. However, we also believe that the combination of ammonia and CO2 presents many opportunities for the future and is the likely endgame solution for industrial refrigeration. By introducing CO2 as the energy carrier in indirect systems with ammonia, we reduce the ammonia charge and thereby increase the system's safety level. Here is a broader overview of the refrigerants. Some of these refrigerants are in the pipeline and others are already out in the market. However, information about new refrigerants is released on a regular basis, so it can be difficult to keep an up-to-date overview. For example, the biggest applications, such as chillers, use R123. But there is already a new non-flammable substitution emerging on the market called use R1233ZD. The red circle around 1233ZD means that it is new and on the market, and the color inside the circle means it is a non-flammable refrigerant. At the same time, you can also see that the GWP level of this refrigerant is very low, below 150, so it is a very environment-friendly refrigerant. If we look at the applications that currently use R134A refrigerant, we can see that there are many opportunities to substitute this refrigerant. R134A has a GWP value of 1500 today, and it is considered a base refrigerant. There are already opportunities in the market to substitute this refrigerant with safety refrigerants such as R513A and R450A, which have a GWP around 630. Some of these are flammable refrigerants, and others are regarded as mildly flammable. Many of the other refrigerants here are still not on the market, but they are being investigated and can potentially be in play, especially because of low GWP values. In Danfoss, we are experimenting with these substances. R452B is a very viable refrigerant, and we think it has a bright future on the market. Outside this scheme, we have, technically speaking, two very different refrigerants here, CO2 and ammonia. And of course, these refrigerants will come into play when we talk about R404A substitution. CO2 and ammonia will be main players in refrigeration and substitute a lot of the R22 industrial systems, especially in developing countries. So, this brings me to the end here. We hope that you now have more clarity on this refrigerant transition. While the situation is constantly evolving, our lab and technical teams are working to ensure that you receive strong support and regular updates on the different aspects of your transition to new refrigerants. Don't hesitate to contact Danfoss for more information or visit our website at refrigerants.danfoss.com. There, you can download our refrigerants white paper, our low GWP brochure, and our retrofit guide. For product selection, please use the web application Cool Selector at coolselector.danfoss.com.